Hello everyone. In this video I'm going to show you how to create a XinuShell command. I'm hoping that this will be really helpful for the homework too. So the first thing, I have created a command to dynamically create a process as described in the homework 2 statement. So the first thing that I do for this is I go into the shell folder in my Xinu root, and here I create a new file, a C file, and I give the convention is like in Xinu the function name and the file name that contains that function are the same. So and the commands for the shell command, for the files that implement the shell command, start with XSH underscore the name of the command. So the name of the command that I want to create is create. So let's open and see how I implemented this. So with this command, what I intend is I want to create a new process every time the user types the create command, the shell command. So this is the prototype for the function. So the first argument is the number of arguments that will be passed to the the number of arguments that have been passed to this create function. So if this is 2, that means we have 2 elements in this array, and each one is a character string. So the first argument is always the name of the command itself. So for this one, the first argument, we will have at least one argument, and that will be create, string create, the command itself. And if you have additional arguments to this function, they will be also in this array as string elements, and the number of arguments, that n args, will represent how many arguments that we have in total, or how many elements that we have in total in this array. So what I want here is that, once the user types create, I want to consider 2 situations where the user does not specify the priority for the process that we are creating, and a situation where the user explicitly specifies the priority. So depending, and in each case, the number of arguments that you will receive and create this function will be different. If the number of arguments is 1 in this function, that means that the user did not provide any additional arguments. So the only argument that we have is the create, the name of the command, without anything else. So in this case, we will set the priority to initial priority, init priority. So this is the default priority that we use. And if the number of arguments is 2, that means the user type create and an integer value. So the second argument is the priority value that the user wants to use. So in this case, and that is also a character string. So in this case, we have to read that second argument and convert that into an integer. And here's how we do that. So we first get the second element, or in our args array, which is again a character string, and we read character by character. And if within this loop, we simply increment the pointer every time we read a character. So right here, we increment that pointer to go to the next character within that string. And if a character that we read within that string is not between 0 and 9, if it's anything but a digit, then we will simply print an error message and return 1. Otherwise, we simply do this to get the integer representation of that string. So if you read this carefully, you will see how it works. It's not that complicated. So once we have that priority as an integer, so the priority, we define that local variable here. So we compare that with the min key. So we don't want the user to provide a priority that is less than the minimum key allowed in our system. If that's the case, we simply, print in a error message and return 1 again. So this else meaning that, if the number of arguments is something different from 1 and 2. So in that case, we just say that too many arguments and return 1. So because we expect either 1 or 2 arguments. So if it's more than that, we simply print an error message. And if we get here, that means we successfully converted the second argument, the priority, into integer. And now we can create a process. Remember that with this command, what we intend is to create a new process dynamically. So this new process will run in a function called run forever. Okay. So, and this is the stack size, and this is the priority that we received as an argument, or the default one, depending on whether the user specified that. And this is the name, test, and this is the number of arguments that the run forever takes. So in this case, it doesn't take any arguments. So, and we just to check if we were able to create the process successfully, we compare the PID, the process ID, with system error. So because the create returns a system error if for some reason it cannot create the process. So if that's the case, we simply print the message saying that the creation was unsuccessful and return 1. Otherwise, we resume the process ID and return 0. So this is how we implement this particular shell command. So now let's take a look at the run forever. So we said that as soon as we type create, we will be creating a function, a process that runs in this function, run forever. Let's take a look at that now. Okay, it's just a simple function that doesn't take any parameters or arguments. So, which simply prints its PID, process ID, by calling the get PID. We know that get PID returns the ID, the process ID of the current process. So we simply print that and then get into an infinite loop. So, and this will keep running forever. Okay, notice that we implemented this function in a run forever.c. So this is in our system folder. So every time you create a new function in your system, you need to include the prototype of this new function in the prototypes.h. So in this case, I provide the prototypes for these 3 functions. I have implemented 3 shell commands that I'm going to demo only one of them. So this is the prototype for run forever. So, and if you have additional functions, you will simply provide the prototypes for each one in the prototypes.h to expose that function to the rest of the program so that they're visible from everywhere. So you use the extern for that purpose. So now let's see how we provide a prototype for the shell command itself. So this is our xsh_create is the function that implements our shell command. And one more thing that we need to do is we need to provide the prototype for this shell command in the sh prototypes.h. So this is a new function, essentially. This is a new function that we just created, just like we did with the run forever. We need to provide the prototype for this one somewhere as well. So, and this is the place where we do that. So sh prototypes.h includes the prototypes for all shell commands. And notice that, this is the prototype for our new shell command that we just created. So now the next step is to go to the shell.c and provide an entry for the new shell command in the command table. So these are the commands that are available in our Xinu shell. So notice that I have created 3 of them so far, 3 new commands. So the one that we've been looking at is the create. And the second argument, the second value here indicates whether or not this is a built-in command. In this case, it's not. So, and this is the function that implements this command. So as soon as the user types create, this function will be invoked, and that function will internally call create and resume, which will create a process that runs in that run forever function that we just saw. So these are the steps that you will follow to create a new command. And just one more thing about one of the requirements. So if you go to the homework 2 statement, the PDF file, so one of the functionality for a command is to create a new process that starts waiting on a semaphore that you created with the initial count of 0 after announcing its PID. So, and then another one that signals a given semaphore ID for a specified amount of time using signal n. So for this one, what I mean is I want you to create a global semaphore that will be used by these processes. So every time you invoke the every time you execute, let's say, a wait command, the wait is the command that you create for this purpose, for the fourth functionality, this will wait on that global semaphore ID that you created. And then when you call signal n, you will signal that global semaphore. So in your main program, you need to initialize that semaphore you need to create that semaphore with an initial count of 0. So, and for this, I will just show that part without going through how to implement these, and that is a part of your homework that you will work on. So let's just go to the semaphore.h. So semaphore.h is where I created this global semaphore ID. So this is the global semaphore ID that I'm going to use to wait on or to signal with my new shell commands. So this is a global variable, and the reason we use extern is to make this visible to all of the program files in our system. And when we go to the main function, I just declare this semaphore ID here without defining or initializing it. So this basically says that this global semaphore variable is defined somewhere. So this is just to make sure that anybody who includes this file, and once you include xinu.h, you're also including semaphore.h, and whoever includes this will be able to see the global semaphore to wait on it or to signal it. But somewhere you need to also define this, and that is the main function where I define that. So let's just go to the main in the system main. So notice that I define that here, the global semaphore, and then in my main I just put this one statement to create a semaphore ID with the initial count of 0 and assign that ID to global semaphore. And after this point, from my shell commands, I can wait on this global semaphore or signal this global semaphore. So now I've already compiled this, so I will just go ahead and restart my BiggleBone and load the this image, the binary. So one thing again, the way I implemented the create command is lets the user to provide a priority value for the process that is going to be created. So if the user doesn't provide a priority, we will use initial priority, which is 20. So, and when we use the constant init prio, to get that value in our function, like we saw. So we'll just wait until this loads. Okay, so it loaded. Let's run. Okay. So now I followed the same steps to create my wait and signal and commands. So I will just demo to see how they work. So now PS is a default command that shows the processes that exist in the system. So when we run, so these are the processes that we have. So every time we run PS, we are actually creating a new process to run that shell command, and that's why we have this the seventh process is the PS itself. So now let's create a new process. So now I'm just declaring that the process has been created by saying that running PID 9. So let's just PS one more time. Notice that, this one right here is the one that I created. So now there's that process in my system. So if I create one more process and do PS again, so notice that there are two processes with that name, because every time when I type create, I'm creating a new process with the initial priority, which is 20. So now let's call wait. Okay, and then let's call PS to display all of them. So notice that now I have a waiting process. So this is simply waiting on that semaphore. So every time when I call wait, I will be actually let's do one more time wait and PS. So now I have three processes that are waiting on that global semaphore that I just showed earlier. So if we do signal N, so this request requires an argument, or if you don't provide, the way I implement it, if I don't provide an argument that indicates how many times I want to signal, the default will be 1, but I want to signal twice, meaning that this is going to signal that global semaphore twice, and that will ready two of these processes. And the way I implement is once they start running, once the wait returns, once they start running again after waiting, they exit. So let's see what happens. Let's see if we can see that. So I signal that twice if I run PS. So notice that there's only one waiting process left in my system because I signaled the semaphore twice. So two of them have been readied and have run to completion and exit. So if I signal to N two more times and say PS, notice that I don't have any waiting processes anymore, the ones that I created earlier. So this one is gone. So and notice that I signaled twice, and although I had only one process waiting. If I say wait one more time and do PS, I don't have a waiting process because the value of the semaphore, that global semaphore, was left 1 because there was only one process waiting. I signaled twice, so the value of that semaphore was actually a positive value. So that's why the next wait that I typed here did not create. Well, it created the process, but it didn't block because the wait decremented the value and it became 0. So if I do wait one more time, now we'll see a waiting process. Okay, so this is how the shell commands can be created and what I want you to implement for the homework 2. And there are additional, commands that I want you to create to simply display the ready list. So in this case, we are displaying all of the processes. So only the processes whose state is ready are on the ready list. So with that command that you will implement, you will simply print this information, or just the process IDs for the processes that are ready or in the ready list. So you will implement the semaphore commands like wait and signal N, as well as the additional commands that are described in the homework 2 PDF.